Hi and hello everyone for who is watching this video. My name is ATHIRAH BINTI HASNIZUL. How are you today? I hope all of you in a good health because today we are going to learn some very interesting topic which is Pascal's principle in 15 minutes. Are you guys ready? Okay, let's start our class now. For everything we do, for every lesson that we go, there must be an outcome that we want to obtain from it, right? So, to start, we go through the objective for our lesson. Since we want to learn about Pascal principle, by the end of this lesson, you should be able to first describe the principle of pressure transmission in an enclosed fluid. Next, communicate about hydraulic system as a force multiplier. Then, communicate about applications of Pascal's principle. Last, solve problems involving Pascal's principle in daily life. But before that, let me do some activities. First, we must have Pascal pistons and plastic basin. The material is like you see in this picture. Interesting, right? Okay. First, fill the plastic basin with tap water until almost full. Then, immerse the Pascal piston into the water and pull the piston so that water enters it. Next, hold the Pascal pistons above the basin and push the pistons inwards. So, what do you think that happened in these activities? Yes, good. We can see the flow of water out of the Pascal piston. Now, let us observe on the flow of water out of the hose when the Pascal piston is pushed inwards. When the piston is pushed, a force is exerted on the surface of the water and pressure is produced. This pressure is transmitted uniformly throughout the water in all directions. This causes the water to spurt out from every hole. This is called Pascal principle. What is Pascal principle? Pascal principle is the pressure applied on an enclosed fluid is transmitted uniformly in all directions in the fluid. Now you know what is Pascal principle of pressure transmission in an enclosed fluid. Next, we focus to hydraulic system. What is hydraulic system? Hydraulic system is a system that uses a liquid to transmit pressure. Now we see simple hydraulic system model. This picture is simple hydraulic system model. How this hydraulic system model is work? As we can see in this picture, input force F1 is applied on the input piston. At the input piston, pressure P1 is produced on the liquid surface A1, pressure is transmitted uniformly throughout the hydraulic fluid to the output piston. The same pressure acts on the liquid surface A2 at the output piston. Output force F2 acts on the output piston. From that, we know the hydraulic system model shows that a force acting on the small piston can produce a larger force on the large piston. This shows that a hydraulic system not only transmits pressure but also multiplies force. That picture shows a hydraulic system that functions as a force multiplier. Here is formula of Pascal's principle. F2 over A2 equal to F1 over A1. F is force and A is area. And this is value of multiplying factor A2 over A1. Next, application of Pascal principle. We only focus just two applications of Pascal principle, which is hydraulic brake and hydraulic jack. So, what is hydraulic brake and hydraulic jack? Let's see. Hydraulic brake. A hydraulic brake system is a braking mechanism that uses brake fluid to transmit force into the system. The fluid transfers pressure from the control mechanism to the braking mechanism. Hydraulic braking systems are widely used in low-speed four-wheelers such as the Tata Ace. It works with the drum type, while the disc type is used in almost all cars. So, how hydraulic brake it works? The hydraulic brakes allow equal pressure to be transmitted throughout the liquid. When the brake pedal is pushed, it exerts a force on the master cylinder, which increases the liquid pressure in it. The liquid pressure is transmitted equally through the liquid in the metal pipes to all the pistons of the other cylinders. Due to the increase in liquid pressure, the pistons in the cylinders move outward pressing the brake pads with the brake drums. The force of friction between the brake pads and the brake drums stops the wheels. Next is hydraulic jack. A hydraulic jack is a device that is used to lift heavy loads by applying a force via a hydraulic cylinder. Hydraulic jacks lift loads using the force created by the pressure in the cylinder chamber. And how hydraulic jack it works? A hydraulic jack creates pressure by moving oil through two cylinders via a pump plunger. The pump plunger is drawn back, which opens the suction valve and draws oil into the pump chamber. As the plunger is pushed down, the oil is transported through an external discharge valve and into the cylinder chamber. The suction valve then closes, resulting in pressure being built up within the chamber, causing the piston in the chamber to rise and lift your heavy object. This process can be repeated many times, allowing your load to be lifted higher and higher. Okay, see, you have already learned about Pascal principle. Let's answer a few questions. This picture shows a hydraulic system. So, from this picture, calculate the multiplying factor and the output force F2. From this picture, we have F1 equal to 12 Newton, A1 10 centimeter squared, A2 50 centimeter squared. Okay, how to find multiplying factor? We know that multiplying factor is A2 over A1. So, we just put the number 50 cm squared over 10 cm squared and the answer is 5. Okay, for the question number 2, the output force F2. We got from the previous question, multiplying factor is 5. Input force F1 is 12 Newton and output force F2 equal to A2 over A1 times F1. So 5 multiplied by 12 Newton and the answer is 16 Newton. Alright, next question is, a technician intends to design a hydraulic brake system for his bicycle as shown. The input force that a cyclist is able to exert is 60 Newton at the input cylinder, which has a cross-sectional area of 0.80 cm². What is the cross-sectional area of the output cylinder that will produce a braking force of 840 Newton? Alright, we know F1 equal to 60 Newton, A1 0.80 centimeter squared, F2 is 840 Newton. Now we have formula of Pascal principle. F2 over A2 equal to F1 over A1. We just put the number 840 Newton over A2 equal to 60 Newton over 0.80 centimeter squared. So the answer is 11.2 centimeters squared. Alright, now is it the end of this lesson. I hope you all understand about the Pascal's principle. Thank you for listening. Bye.